This short video will show you how to use RStudio for doing classification tree. First, you need to install the package called Party. There are other types of classification methods. So there's something called rpart and other things. We'll only look at this one method, which allows you to do what we call conditional inference tree. Sorry, I made a mistake here. It should be within double quotes. So once you install that, then say call the library Party. So once you've done that, let's go ahead and pull the data. We'll look at the same example, wine. So let's import the data set, wine, say open. So make sure that you click yes for the heading. So now that we got the data, so what we need to do is develop a classification tree where the leaf node or the nodes at the end of the tree is basically whether you have type A, B, or C. That's a type. So we want to make the decision based on various attributes of this wine, from alcohol, malic acid, ash, and so on. So we want to use some of these variables to develop this tree. Okay. Now, as we discussed earlier, we need to first, we have about 173 data points. We want to classify this data set into something for training the classification tree, and the rest we're going to use it for testing. If you recollect, we had three types of sets: training, validation, and testing. In this case, we'll just use training and then build a classification tree and test it on the rest of the data, 30% of the data. In order to do this, you randomly select records from this Excel spreadsheet. So you want to set the seed, set sort seed. I'll just give some arbitrary seed value. The why we do that is you can replicate the same result as long as you have the same seed. Theoretically, if you have a large number of data points, you see the results irrespective of the seed will converge. Sometimes when you have small data set, different seed, starting seed might lead to a little bit of different results. But again, it all depends on the sample size. Large sample size, you don't have to worry about that. So now we'll take this data that we have, 173, classify them into training data and test data. So how do you do that? Let's call it int sample. You sample into two different groups. The rows from the file wine. Remember the data file that I have, the wine is uppercase, W is uppercase, so I'm just putting wine. Okay, and then replace equals true with probability equals C. C 0.7, that is the first one is 70% training set and the rest 30% for validation set. So once you have created that, so basically in some sense you are identifying each row by either it is a 1 or 2. 1 means it is for training, 2 means it is for testing. That's what it does, 2, sample equal to 2. So let's call the train.data wine with brackets int 1. So what it means is it takes that wherever you assign 1 to that row, you put them in the training data. Make sure that you have brackets and not parentheses. And then I have test.data wine int 2. So wherever the row is marked as 2, we are extracting the test data. So now that we have As you note that I got an error here, that's because I put here less than, it's minus rather than equal to. So we got the training data and the test data. So the question is now you got to pick a set of variables from your data set that has implications for your classification. You can choose to take all the variables, or you can pick the ones that are most relevant for you. Now, how do you know what is relevant? Is take a mean, take the standard deviation, and you tend to see wherever there is little bit of variation probably explains little bit more. If all column has the same value, a column has exactly same value, no variance, obviously it has no implications for your classification. In fact, for even for your regression, if there is no variance, then regression doesn't say anything much. Okay, so we'll include can exclude. Now you can, I'll let you do that identifying which. I'm going to just pick some 4 or 5 variables just for demonstration purpose. I'll call MYF. Okay. So your type is your dependent variable, and your independent variable is type. I think you use the word tilde here, alcohol. Make sure that your A is uppercase in this alcohol, exactly like the one you see in the column heading. Okay. Alcohol plus ash alkalinity plus, I want to take just few others. I'll call it flavonoids. Flavonoids is probably has some explanation. And then I'm going to take the last one, let's say proline. So I picked 1, 2, 3, 4, 5 variables here. So that's your formula that you're going to look at. So I'm going to develop wine underscore C tree. So this is what we call the conditional inference tree. So we have a built-in function for that C tree. You pick that model my formula, and the data is your training dot data. So you're developing this conditional inference tree from your training data using those variables that we have stipulated in my f. It has now developed the tree. I want to see how well it does this tree works. So you know the original. The original is ABC. You know that for each row, and I want to see this tree how well it does. Is it fairly good? Has got a lot of error. That's what we are. So table predict wine underscore C tree, and I'm going to pick that train.data $type. So I'm basically creating a table based on your tree that you have and the actual data that is there in the training data type. So it basically gives you a type A actual, A predicted. How was it? So if you see the one in the rows ABC is what you see is the actual ones, and the ABC in the column is what it is predicted in the tree. So you see that for A, out of 48 items that it has picked randomly, 46 it is accurate, 2 is misidentified. Likewise for B, you see about 6 misidentified, and C you have 2 misidentified. So you have about 10 data points that are in error compared to the actual. Not bad. Maybe if you add more variables, you might get more accurate data. Okay. So let's look. If you want to visualize this, you can visualize the data. Let's say plot wine underscore C tree. So if you plot it, you can actually see how it looks, how the tree looks like. So how do you read this? Flavonoids less than 1.22, alcohol less than 12.6. You have N7, that is 7 of them are there, and you see 70% is C and less is B. Let's take this one particular Example here, flavonoids greater than 1.22, proline is less than or equal to 750, alcohol less than 12.77. There are 42 items here, and it has predicted accurately, all of them. Likewise in the last one. Okay, so these things you can get to see what is the error rate in your actual model. Okay, so 10 out of close to 48 plus 54 plus 31. That many data points, you have an error rate of 10. 10 divided by 130 something. So that's your error. So now this is based on the tree that you have developed. Now I want to use this tree what you have developed on the rest of the 30% of data to see how well it predicts. So I want to call it test predict. Means you're applying your tree on the 30% of data set now. Predict wine underscore c tree new data. You're using the new data, that is a test dot data. So is the spelling here predict. So once you've done it, so it predicts to see what do you predict for the rest 30% of the row, and now comparing the actual type with the predicted type. So table test red test underscore dot data dollar type. So it takes a predicted type and the actual type that is listed in the training data set. I'm sorry, the test data set. If you put it, it will show you there are 12 data points for A, 1 is misidentified. For B, you have 18 data points and 2 of them misidentified. Likewise, C is 2. This is fantastic data in some sense because you had 12 plus 18, 30 plus 15. You had 45 data points for your test data. Out of that, you have 5 that are in error. So 5 divided by 45. So again, you see about 10% error rate. That's not considered to be bad in any sense. So if you can give any arbitrary content of the wine, you should be able to predict what type of wine it is. Okay, now you can apply this concept in, for instance, for loan data. And see, you take the past loan data, you apply these classification methods and see what is the error, and you can come up with some sort of a penalty. So if you misidentify a good customer into bad, you lost some profits. If you give money to a bad customer, then you might lose the entire money that you have given out loan. That's a huge penalty. So the penalty that you have is not symmetric, it's asymmetric. So if you give loan to a bad customer, then the penalty is probably much higher than the potential opportunities that you might get by denying to a good customer. So you can come some sort of way you can analyze the penalty function to evaluate how good this is. Okay. So that's about using classification.